3.
Hi, Dr. Smith. It's Kara.
And I'm Kaya.
So we're roommates and we're in the same section for Math 313, and so we're just going to do this video together. I'm just going to move the camera down so you can see our work better. Okay. So we have already traced our given triangle so far on patty paper, and we are going to take the two angles provided in the given side without changing the length of AB, and we're going to use a straight edge to complete our triangle, and then we're gonna compare our triangle. So we are just going to make a triangle anyway. Okay, so we made our triangles and they look, they're different of course, but they do look pretty similar. Our vertices are a little bit different, but this triangle, this theorem is angle side angle, and this is because A is an angle, and then we have this length of AB, so that's the side, and then we have another angle B. And the angle side angle theorem means that if two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the two triangles are congruent. So that is the angle side angle theorem.
And then moving on for exercise 2, and we did the same thing where we already traced it out on the patty paper. And then what we're going to do is take the angle provided at point B, mark it, and then the two sides AB and BC, and same thing as without changing the given side lengths nor the given angle at B to complete the triangle. And then now the triangle we've gotten is a side angle side, and then we have line C and B as first side, and then we can mark point B as first angle, and then side AB as the second side. And then what side angle side is when two sides and the included angle of one triangle are congruent to the two sides and the angle of another triangle, and then the two triangles will be congruent together. And then for exercise 3, we're going to take the 3 line segments, and without changing their lengths in any manner, we're going to create a triangle with the given line segments. And so basically we're constructing this triangle with the given 3 line segments as we did in the previous class. So you're going to take the compass, and you're going to take it out. Wrong side. And you're going to stretch it out till you get to the end of the point, and we're going to bring it down here. And we're going to mark it like that and point, and then back down. Mark here, so this is going to be our line, so you can just take your straight edge and then just, oh gosh, my nails. And then just make a straight line from the 2 points. And we're going to go down to the second line segment and bring it down. out to right here. Then we're gonna go to the start of the line segment here. And then we're gonna make an arch at this point. Like that. And then we're gonna go back up into the final leg segment. Here. And then we're gonna go on the opposite side. And then we're gonna do it again. We're gonna make an arch. Okay. As you see, I did not do the arch big enough, so there's a little bit of a gap. So I'm gonna go back real quick and tie it back up. Okay. Thank you. Okay, so now we got both arches, and then when we meet at the vertex, you're gonna take your straight edge here. You're gonna make a point, and you're gonna take a straight edge, and you're gonna make a line, and then that's gonna be your first line. And then you're just gonna come down here. And then you get your triangle with the three sides. And then it came out as we made a right triangle. And then this angle that we got is a side, side, side. And then that means the three sides of one triangle are equal to the three sides of another triangle. So then that all the two triangles you would have would be congruent together. And then comparing the triangles into the other exercises. Compare all the triangles created given these line segments. Are there any differences? How do you know? Do you recognize side, 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 and how? And be thorough in your explanation.
So I think that for number 3, this triangle is a right triangle. And of course I haven't measured the angles, but they look pretty close to right. So that's kind of like a similarity. A difference that I notice is that they have different theorems. So this one had angle, side, angle. The one for number 2 had side, angle, side. And then this triangle has side, side, side. So a difference I notice is that they have different theorems. So we're going to move on to number 4. So we have been provided with a triangle, of course, and we have been given a dotted line right here at angle off of point A, and then we have A, B that we cannot change the length of, and we can also not change the length of this line segment L that we are given. So we are going to, I already traced this segment onto patty paper, and we have to connect this line segment from B. We have to connect it to point B. So I'm actually going to draw this on patty paper to make it easier to be able to trace that line segment so I don't change the length of it. So I'm going to take this line segment L, and I'm just going to connect it to point B, and just make sure you can see. Yeah, thank you, Kaya. And actually, just want to make sure. So I'm actually gonna draw side A first, just so I know how long it needs to be. And then I can draw the line segment. And so here's the triangle that I have created. I didn't change the side of A, B, and I did not change the length of the line segment that we were given. So to answer the questions, can you make more than one triangle from the two sides and they're not included angle you have been given? Actually, you can. You can, yes, because you know, you could always make this line A, we'll just call that C. You could always make that segment longer and then bring this out more. So if if Kaya and I were to make, like we did in the first question, and we were just to make our own triangle with two sides, we would probably get a similar triangle, but it would be different and it would be a different angle. And what is this for part B? What does this have to say about congruence of triangles made from two sides and their non-included angle? So that would be called an angle side-side theorem. And that angle does not exist because an angle and two sides does not guarantee that two triangles are congruent. So we cannot say that like this angle and this side are congruent. That theorem does not work because that theorem cannot guarantee that a triangle is congruent.
I agree.
So that is all we have for today. I really hope you enjoyed our video. We tried to be as visual as possible for you to be able to see our drawings. Thank you so much for watching.